everybody. Today we're going to continue on with graphing up our rational functions. The only new thing we're introducing is a possible slant asymptote. Like before, what we want to start doing is just begin by factoring. So this guy's going to factor into x minus 4, x plus 1 all over x minus 2. I notice that none of the factors cancel. That means that we have a hole in the graph. As always, our vertical asymptotes come from driving the denominator to 0. So that's going to be the line x is equal to 2. Now looking at the exponents on the leading terms here, we have a 2 in the numerator and a 1 in the denominator. When the exponents are higher in the numerator, that means we have a slant asymptote, not a horizontal. And horizontals and slants cannot exist at the same time. X-intercepts come from setting each factor in the numerator to 0, so we'll have one at 4 and at negative 1. So there are our x-intercepts. Y-intercepts occur when we plug in 0 for all the x's, so we're going to get a y-intercept of 2. Slant asymptote you derive by taking your numerator and dividing it by your denominator. We're going to use our synthetic division for this. So we have a 0 of 2. The coefficients are 1, negative 3, negative 4. Bring down the 1. 2, negative 1, negative 2, negative 6. For our purposes here, the remainder is so insignificant it won't be part of our slant asymptote. Since we began with a quadratic, the next one down will be linear. So our slant asymptote is going to be x minus 1. We're going to put that into our graph. We have a y-intercept of negative 1. With a slope of 1, and there is our slant asymptote. At this point, we're just going to start pulling points off of our calculator. So we're going to be at negative 4, negative 4, 1, 6. So negative 4, negative 4, 1, 6 was up here. So this guy's hugging real close to both of those asymptotes. And then on the other side of that vertical, we have 3, negative 4, and 5, 2. So 3, negative 4, 5, 2, and this guy's hugging real close on this side. All right, so moving on to example number 2. I'm scooting the paper down here a little bit. First thing I notice is that I have a constant in the numerator, so I'm guaranteed that my exponent in the denominator is bigger. So therefore, we're definitely going to have a horizontal asymptote for this one. No factoring to be done in the numerator. It is a difference of 2 perfect squares in the denominator. Since nothing is canceling, we have no hole in the graph. Our vertical asymptotes come from whatever's going to drive that denominator to 0. So x is equal to negative 2 and x is equal to 2. We have a horizontal asymptote at y equals 0, since the denominator's exponent is bigger than the numerator. Since there is a constant in the numerator, we will have no x-intercept. Y-intercepts come from plugging in 0. So we're going to have negative 5/2. And if you have a horizontal, you cannot have a slant. So what we know now, we got vertical asymptotes at x equals negative 2. And x is equal to 2, a horizontal asymptote right over the y-axis there, and a y-intercept at negative 5/2. Just pulling off the points that we're looking for, we got these off the calculator. That's on the left side here, so negative 6, that was real close there, negative 3, 2. Top part was hugging close to the asymptotes. For the middle section, we got negative 1, negative 3.3, and 1, negative 3.3, causing an upside down parabola in this middle section. And then lastly, we have 3, 2, and 6.3, and causing another hugging along the asymptotes there. All right, let's move on to example number 3. Alright, first thing, as always, we're going to factor. I am noticing that my exponent in the denominator is bigger than the numerator. That's going to leave me with a horizontal asymptote at y equals 0. If you have a horizontal, you cannot have a slant. Factoring. We wind up with x minus 5, x plus 3, and we notice that we have factors that cancel, so therefore we have a whole. The x part of that whole is going to be negative 3, and we get the y part by plugging negative 3 into what's ever left over, so in this case it's going to be negative 1/8. So we've got a whole sitting real close to that x-axis. The vertical asymptotes come from what drives the denominator to 0. X-intercept, since we only have a number, no variables in the numerator, none will exist here. The y-intercept will occur by plugging 0 in for x, and we're going to get 1 at negative 1/5. So all this stuff is just sitting real close to that x-axis. At this point, we just need the points that we're pulling off our calculator. And on the right side of that vertical, so we go, this guy was real close. Oh, it's on the other side. And yeah, let's get that correct. It's on this side. And then for negative 1 would be about here. So, and there's our horizontal asymptote. So this guy's coming to the hole, picking up on the other side, hugging down this way. We have 6,1, 9.25, and this guy looks like that. Remember, guys, it is okay to use your calculator to look at the graph. You just need to emulate the points for us. Okay, this one here, there is nothing to factor. What I am noticing, it is unfactorable. That is also an imaginary solution. We have no holes. Since we can't factor or solve that denominator, we have no vertical asymptote. The horizontal asymptote, again, because the denominator is bigger than any exponent in the numerator, is going to be the x-axis, or the line y equals 0. X-intercepts, we have no variables in the numerator, so none would exist, which makes sense because the asymptote is sitting on the the x-axis. Y-intercepts occur when we plug 0 in for x, so we're going to have a y-intercept at 6. Since we have a horizontal asymptote, we cannot have a slant. At this point, you go to the table on your calculator and grab some points. Some on each side of the vertical asymptotes. And this guy winds up looking kind of like real close here, then at 3 and 3 and here. Just kind of coming along like this and then heading out towards positive and negative infinity. All right, number 5. Just put this down a little bit more. I'm going to start by factoring. I do notice that the exponent in the numerator is bigger than the denominator, which opens us up to a possible slant asymptote. So we start factoring. We get, let's see here, x times x squared minus 9 all over x minus 3, x plus 1. The numerator continues to factor with the difference of two perfect squares. And I notice that I have two that are the same that are going to cancel out. So we wind up with x times x plus 3 all over x plus 1. The hole in the graph is going to come from an x coordinate of 3. When I plug 3 back in over to all these x's, we wind up with 9/2. So we're looking at 3 and 4.5. So there's a hole sitting there. The vertical asymptote comes from whatever is going to drive the denominator to 0. So we're looking at a vertical asymptote sitting right over here. The horizontal asymptote is not in existence here because the exponents here are higher. Alrighty, so we're looking at no horizontal asymptote. X-intercepts are going to happen from what makes the numerator go to 0. So we have 1 at 0. We also have 1 at -3, so 0, -3. Y-intercepts will occur when we let everything go to 0. Since we have an x-intercept of 0, the y-intercept will be 0 as well. And again, that slant asymptote comes from dividing the numerator by the denominator. We could use our synthetic division. Again, we'd get -2 over here. The denominator, or the remainder, is not any part of this, so we're going to line up with the line y is equal to x plus 2. So we're going to go to +2. We have a slope of 1, getting in our slant asymptote. And then just grabbing some points here. We're looking at -2, 2, -4, -1.3. So -2, 2 would be here, 4, 1.3 would be here. This guy winds up hugging along this way. I only got the 1 point here because I already had the hole in the y-intercept, and hugging along and picking up on the other side of the hole. All right, we've got one more to go. We're going to start factoring here. I notice, -1. I notice that is still factorable, so I'm just going to continue into x plus 1, x minus 1, all over x plus 1, x minus 1. And we have two things that cancel, which means we have two holes. What we're left with is just a constant of 2. So what that is creating is a horizontal line at the constant of 2. The hole is going to be at -1, 2, and 1, 2, because all y values are 2 on that constant. We have no vertical asymptote. The denominator's been wiped out. We have no horizontal asymptote. All the x's have been canceled out. No x-intercept because there's no variables left. The y-intercept has to be 2. We are at a vertical line of 2. And no slant asymptote. We don't need points because this is a horizontal line at y is equal to 2. So the only things we've got to get in there are the two holes. And there is our line. With that, we wrap up Unit 7. Good luck with your practice, everybody.